All right, we have a display. Excellent. Hi, I'm Joff. Sorry for the delay. Are we good? Recording? All right, thanks for coming. I hope everybody's having a great time with Wild West Hackin Fest. I know I am. I am not a fan of podiums, but I'm told I have to stay here, which is extremely irritating for the best. But anyway, smile, everything's good. All right, so I thought about this talk, and I've got a slide deck and everything, but I thought, wouldn't it be fun if we just took a Python script that's written in Python 2 and try to run it in Python 3 and just watch what happens? Because why not, okay? And by the way, if you're here for Derek Rook's talk, I am not Derek Rook, I'm Joff. We switched, okay? Derek's a lovely bloke, though. All right, so here we go. I'm going to try to type and talk at the same time. I've got this little project I worked on quite some time ago. It's called DNS Black Hole. And what this thing does is it takes a URL and it builds a bind9 zone file to black hole domains in DNS. So the idea is this, right? In Python 2, I can run this script, okay, and I can feed it a URL like, oh, we got to look one up now. Like, let's see, who knows the URL for the dshield, dshield block list? Oh, that's a bummer. Okay, the live demo is not going to work because no internets. Boy, it's really my day. It really is. Let's try again. All right. Anybody want to throw me a Wi-Fi? Let's try DMG. Let's see how that works. Yeah. All right. Login password. Whiskey Tango Foxtrot. They cut us off. All right. Let's go with Wild West Hackin Fest. All right. Anyway, the idea is this. I think I ran this before, so I'm going to look in my history real quick. History, grep, dshield. All right, here we go. There it is. Okay. But I'll run it with Python 2. All right, we'll try this. DNS black hole, HTTPS, and cut and paste would be awfully helpful at this point. Suspicious domains, okay, low.txt. And the idea of this script is if it can talk to the internet, it will go out and it will fetch a list of domains that it will then turn into a bind9 zone file, and then you can feed it into bind9, and it will block the resolution for anything that's in that domain list. And by block, I mean it'll resolve to 127.0.0.1, right? Apparently, I don't have internet. But anyway, let's take this script and let's try to run it in Python 3. Oh, man. That sucks, right? So the very first thing you run into with a Python 2 to 3 conversion is the print statement, and that's usually universal. The print statement in Python 2 has become a function in Python 3. So what you do is you're like, okay, well, I can fix that. So I'm going to go find all the prints in my script, and I'm going to put parentheses around them, right? And I'm going to hope that my print statements work. All right, so this is like live coding here. Almost anything could go wrong at any moment, okay? By the way, this is a pretty short project. I think I just missed the close parentheses. All right. See, I think we're almost there. We'll find the error. Oops, line 122. All right, how's this? Live coding. Mark, I hope you're holding my beer over there. All right, thanks. He's got me. All right, here we go. We're going to run it again. Oh, man. Module not found. No module name URL lib2. Oh, thanks, Python. So the Python gods, in their infinite wisdom, this would be Guido and the gang, as we like to say when we're teaching Sec 573. See how I slid that in there ever so subtly, right? The Python gods, in their infinite wisdom, decided to rename URL lib2 back to URL lib, if I remember correctly. Well, that's a bummer. So how are we going to fix that? Okay, let's edit the script. Let's go to URL lib2 here, go back to URL lib, and let's try to run it again. Hey, we got the help screen. Life's looking pretty good, right? I think this little script might run. I'm getting really excited at this time, right? All right, so let's try it with the URL this time. This assumes that I have some internet, which of course I probably don't, but we'll try anyway. What happened? Huh? 0 domains. It didn't look like it even tried to go and talk to the internet. Like it looked like the URL request failed. So let's try to find that URL request. So there it is, and I've got it in a try except block. So let's drop a little bit of exception handling in there so that we can see the error instead of just continuing through the loop here. Of course, you have to be familiar with the script and see what happens. Name URL lib2 is not defined. Well, crud. All right, I'm going to stop because this is becoming painful at this point. And let's actually talk about the presentation itself, right? Oh, really, PowerPoint? Really? Okay, this is like, apparently I haven't prayed to the demo gods enough this week. All right. Come on, baby. You can do it, baby. Come on. Who's this Joff guy? Very, very quick. Pen tester, researcher, developer, SANS certified instructor, Sec 573, Security Weekly co-host, and I have to say sorry about that. And if you want to find me on the Twitters, at Joff Thyer. Okay? Done. There it is. Now, what's really happening here with the Python 2 to 3 transition? Well, we have significant changes. Now, Guido and the gang decided to do us a big solid favor, and in most versions of Python, they implemented this cute little thing called _future_, which is a module to give you forward compatibility with Python 2 to 3, typically, but even earlier versions, right? And for the most part, it works, and there are features that you can use. So what I'm going to go through is basically a list of key differences that, frankly, we teach in the Sec 573 class, at least until we switch to Python 3 exclusively, which will be next year. Okay? So let's talk about it. First of all, in 2020, Python 2 officially becomes end of life. In fact, there is a Python enhancement proposal called PEP 394 that states the Python command on a Linux-like system, and that probably includes all the BSD variants, should invoke Python 2. Okay? PEP 394 might well change, although it's hard to know. The language is a little bit ambiguous, right? But there is certainty about this. Maintenance releases of Python 2.7 will cease in 2020. So what is this going to mean? Well, the first question that I ask for myself is, what are the Linux distributions going to do? Now, it's anybody's guess. I'd like to see if Mark has a comment on this one, actually. So I'm going to invite him to comment on this. I suspect nothing. Why? Well, frankly, when you install Python 2 and 3 on a Linux system, and you're perfectly welcome to do both, the Python command's just a symbolic link, and it points to Python 2. All of your sysadmins and various people running that system have probably written years and years of accumulated scripts that function perfectly well in Python 2. If the Linux distributions decide to switch the symbolic link to Python 3, there's going to be a lot of scripts that will probably break. Okay? Avoiding breakage is the reason PEP recommends Python 2 continue to refer to Python 2. Sorry, Python. Okay? So I suspect the Linux distributions are not going to move too quickly. Now I'm going to quickly invite Mark Baggett. What is your opinion, sir? Mark Baggett agrees with my assessment. Okay. If the Linux distributions make the move, how much do we really care? If you're a systems administrator in a large organization running many different Linux distributions, such as Red Hat and the like, how hard is it really just to change the symbolic link back? Okay? Maybe it will get annoying because every time that system patches, it will probably revert the symbolic link. But honestly, it's a 2-second problem. Now back to the future. Kind of like using this little meme, right? Example Python statements. Python 2.7 has the ability to be forward compatible with Python 3. The double underscore future module gives us some of this forward compatibility ability, okay? So the future directive is such that a particular module that needs to be compiled using syntax or semantics that will be available in a specified future release, you get the idea, right? You can use future syntax, future functionality in the interpreter in various areas. The two most important ones that we have run across in our live teaching is the division and the print function. Core language keywords slightly change in Python 3. Print becomes a function rather than a keyword. I never understood why print was a statement in Python 2 to begin with. It was always awkward. It always seemed a little out of place. So this is not too hard to deal with, let's face it. Next, division is not what you think it is. Something we also teach in the class. Division in Python 2 is the same as the floor operator, is an integer-based result, and the remainder gets dropped. Now, if you make the operands floating point, then the division becomes floating point. Python 3 is not like that. All division is floating point. So you may run into a challenge. Okay? Example, Python 2, division. Notice 10 divided by 3 is 3, remainder 1. 10 divided by 3.0 is 3.3333, etc. Right? If we import division from the future, 10 divided by 3 becomes 3.3333, which is what you'd expect. Python 3, it's automatically floating point regardless. The double slash is what we call the floor operator, which forces an integer-based division. Print becomes a function. Simple. Print hello in quotes becomes print open parentheses, quote, hello, quote, close parentheses. Okay? It turns out that you can do that anyway. If you use print parentheses, hello in quotes, and close parentheses. In Python 2.7, that is the same as printing a tuple. So you will see these little these little parentheses on the screen. A little bit weird. Import print function from the future, everything's going to work in Python 2. The end of line character changes in Python 2 to 3. Python 2 had this weird, odd little behavior where you could suppress line endings by appending a comma to the end of the print statement. You cannot do that in Python 3. There is a special parameter to the print function called end equals that you just specify, and it works. Format strings. Now, I love this change. I used to argue with Mark. I like to pick on Mark because he's in the front row, or nearly the front row. I used to argue with Mark, man, Python 2 format strings are awesome. I love them. I never will move away. I can't stand Python 3 format strings. So it turns out in Python 3, they actually adopted the C# style format strings, which I think was a really intelligent move. Now, the very latest releases of 2.7 also will format and print with Python 3 style format strings, which actually surprised me. I was teaching that wrong for a while, but it does, which is kind of interesting. In Python 2, format strings are the old style that are borrowed from the C and C++ languages. I know I'm making you dizzy by going back and forth here, but if you go to Python 3, the C# style is actually more useful and more flexible and more powerful. It uses a curly brace, then an argument number, a fill character, alignment, length, and type. And so you can be very specific. The alignment can be center with the caret. It can be left, or it can be right with the less than and greater than. Okay? And the types are all the same as Python 2. So they're very, very powerful format strings. Couple of quick examples, right? Name equals Joff. Print hello Joff with centered in a field 8 wide with a space filling in front of it. Very, very powerful way to format and display data in Python 3. Okay? And I frankly have finally become a huge fanboy of the Python 3, aka C# style format strings. Raw input. Oh God, I got to do a demo on this one, Mark, right? Let's go. Raw input, here we go. Come here, terminal window. Anybody ever seen this? Python2, this is Apple's Python2. Oh, come on, give me a break. Check this out. Actually, sorry, not raw input. I'm going to use input. All right, here we go. This is how you get input from the Python interpreter, right? All right, I'm going to enter a number. Now let's look at that variable A. What happened? Anybody? Yeah, it added my numbers up, right? It like evaluated that as if it were a mini script, in other words, right? Now, this could be bad. Let's show you how this could be bad. Anybody see where this is going? That might be suboptimal, right? So Guido and the gang in Python2 said, hey, this is bad. We should fix this. So they came up with this thing called raw input. And raw input does this. It just returns the object as a string, right? So if I try to do that same trick, congratulations, I got a string that looks like a system command. Okay, so this is awesome. Now, here's where it goes off the tracks. In Python 3, they said, hey, we like that, so we're going to implement the input function, only we're going to fix it this time. Meaning that input in Python 3 works the same as raw input in Python 2. Thus giving a forward compatibility issue immediately. Okay? Highly irritating, because if you have been using raw underscore input the entire time, you have to change your script, or you have to pull a little trick like reassigning the input symbol to the raw input symbol, and otherwise doing nothing, which there's a way to do that with a try except block, but I don't have time. Strings are no longer just byte sequences. Python 3 treats all strings as UTF-8 encoded, meaning it now recognizes internationalization, which is a good thing. In Python 2, strings are just ASCII characters, right? Sequences of bytes. So this is cool, but as soon as you try to code your script in Python 3 and you try to manipulate your strings, you get very frustrated. Has anybody got an example of where they tried this? They want to yell out, oh my God, why doesn't it work? Or something like that. Anybody? All right, yeah, so I see a few hands, right? It's irritating. You just have to know what UTF-8 is. The default encoding in Python 3 is UTF-8. UTF-8 is a flexible encoding standard, very quickly, that allows us to encode characters up to just over 1 million, depending on what the most significant bits of the first byte encountered are. So it's either 0, which is 7-bit ASCII, 110 turns it into a 2-byte character encoding, 1110 turns it into a 3-byte, and 11110 turns it into a 4-byte encoding, which is, frankly, awesome. We can represent really cool things, such as the symbol for a Python in our Sec 573 slides. I don't know how long it took Mark, I'm going to pick on him again, to search down the Python symbol, but he found it eventually, which was kind of fun, right? 128013, even I remember it now. It's crazy. All right. So that's cool, but how do we deal with the bytes? Well, Python 3 has a bytes object now, which is, from a data structure point of view, equivalent to a Python 2 string. Now you have to have the way to convert between byte objects and string objects now that string objects are represented as UTF-8. The way to do this is the Python 3 string object has an encode method which by default will encode strings back to bytes, and Python 3 has a byte decode method, this is a method of the byte object, which by default will convert bytes back to strings. Once you learn that and have cemented that in your head, all of the frustration of handling bytes and strings goes away because you have learned the secret, right? So that's really, really important. Now, related to this, the file object modes in Python 3 have been added to recognize text and binary. And the way I like to explain this is that when you open a file in read text mode, the objects returned are going to be string objects, meaning UTF-8 encoding, which is the default encoding. When you open a file in read binary, or write binary for that matter, then the objects you are dealing with will be byte objects. So if you are processing binary data, then treat the files as binary, and you will not have a problem. Handle everything in byte objects. The other lovely thing that this does for you is that it handles carriage return line feeds as well in text mode. Thank you, Microsoft, for 40 years ago deciding that they had to be different than AT&T Unix. I guess they didn't want to get sued, and they made an executive decision. But for anybody that has dragged a file from their Linux system over to their Windows system, opened it up in Notepad, you have all experienced the frustration of all the lines of text being crammed up into the window, and you have all beat on your screen a little bit, researched a little bit, and then gone, oh my God, it's that line ending thing, all right? So Python 3 properly handles line endings. Very nice. Just by way of example, I can open bin bash, I can read 40 bytes from it, I can look at the object in Python 3, and it is a byte object. I can open etc password in read text mode. I can read the content, and the type of that object is of class string. So you can see the differences there. Interesting features in Python 3, which I call good value-add changes, enhancements, however you want to look at them. But Python 3 has moved away from being so list-intensive for various built-in functions. These include things like the range function, the map function, things that normally would return a Python list and consume additional memory, now generally will return something known as an iterable generator object, which you can loop through, but if you want a list, you will have to cast to a list. Okay? So by way of example, I think I've got one here. If I were in Python 3 and I wanted a range of numbers, so it appears to me that my Python interpreter wants to talk to the internet when I start it up. That's not suspect at all. Come on, come on. Never mind. If you wanted a range of numbers and you wanted a list, you have to use list around the range function, otherwise you get a range object. That's the short version of it. Dictionary changes. Python 3 dictionary methods will now also, in true memory savings style, return an iterable object called a view rather than a list in the old dictionary methods that were in Python 2. Now, interestingly, Python 2 did sort of go halfway. They have these methods called iter keys, iter values, and iter items, which do return iterable objects. But Python 3 just decided, let's do away with that and return a view, which are all going to be iterable view objects. Now, the nice thing about a view, I'm going to skip this slide. If you were to create a dictionary in Python 3 and then loop through the keys and then just for fun create another key value pair, that variable that I use to save the view of the keys automatically gets updated. In other words, the view is automatically and appropriately changed in memory. It's a great feature. Variable scope in list comprehensions has changed. This is a bug fix, in my opinion. If anybody knows list comprehensions, in Python 2, the variable that you use for the iterator variable in the comprehension is considered global scope. In Python 3, the variable that is used inside of the list comprehension has a local scope, which I consider to be a bug fix. When you look at this slide, you can see I have a variable x set to 999, and then I use a list comprehension to create a new list. I use that same variable name, x, inside of the list comprehension. Notice how the variable x that I assigned in the beginning has not been impacted by the execution of that list comprehension. In other words, those two variable x's have a different scope. Helpful resources, there are tons of things. I would be remiss if I did not point you at the SANS Sec 573 course. You have basically got a brief view of some of the conversion-related slides that we collectively teach, and I say we because, again, Mark's in the room, in the Sec 573 class. I highly encourage you to take Sec 573 if you have the opportunity. We believe that it is a core skill in the information security community and that you should use this knowledge in your information security life. Now, I want to show you one more thing. There is a lovely script called 2 to 3 that actually allows you to take a Python2 script and just convert it into Python 3. And it shows you a diff on the screen. So all that manual editing I did can actually be done for you. Now, is it perfect? It is not perfect. For example, if you have string and byte objects in there, you will not necessarily get that issue handled for you. You may have to still do some manual editing. If you want to learn more about that, again, come take the class. We'd love to have you. In the 2020 update, we are going to talk a lot more about 2 to 3 and what it means to convert a script. Finally, there is an online converter that I stumbled across, and just for fun and games, I decided to paste a little bit of Python 2 into the online converter and see what it would do. And so I used a dictionary, I used the iter keys method, I used a print statement with a suppressed line ending, and I used a division, although I forgot I should have just done an integer division. And the online converter did a pretty good job. Now, I don't know who wrote this converter, but hey, it's another resource to look at. So consider that as you're looking at your scripts, and also consider the 2 to 3 project. So I'll stop there. That's been a very swift run through some of the things that you will encounter and how you need to approach them as you're moving to Python 3. And frankly, the time is now. Python 2.7 is no longer going to have a release after somewhere in mid-2020, right? I think it's about June. Okay, any questions, concerns, or otherwise comments for me? Yes, sir. Speak up loudly, please. I think if I'm hearing the question correctly, our Lambda function's going to go away, and I'm paraphrasing that. Is that correct? I don't think Lambdas are going to go away, to be honest. So I'm not quite sure whether I quite heard your question, but I don't think Lambdas are going away. Just the 2.7 Lambdas? I don't believe so. No, I don't believe 2.7 Lambdas are going away. Another question, I think, somewhere here. Okay. Well, thanks for coming, everybody. Enjoy the rest of the conference. It's really great to see everybody, and appreciate you being here and at the talk. Okay?